We can now get started with routing at the HTTP layer now that we have all the store methods to interact with the database. So here we have the layered architecture where we previously worked on the store methods. Now we can move on to the handler and the server layers. So the server layer is where we usually have our business logic, but please keep in mind that we're going to keep it simple because we're going to replace that with a gRPC server in a later video. For routing, we're going to use Golang framework because I want to use packages that's close and compatible with the standard Go package, like how I use SQLX for SQL queries. Golang is compatible with the net HTTP package provided by Go, and it also provides modular APIs that allow us to easily build middlewares and route groups. And you'll see what this means as we work on our routing later. And these are the routing endpoints we're going to work on for products and orders. But please keep in mind that we're not going to be working on the orders endpoint for the patch request to update the order status yet, and we're only going to work on that when we are building the notification system. And in future episode, once we have the user authentication in place, we're also going to have authentication and admin middlewares to only allow authenticated user or admins to access certain endpoints. I'm going to start from where we left off. Inside our ecom API directory, I'm going to create a directory called server and create a file called server.go. I'm going to name my package server and paste what I have already prepared to save us some time. As I mentioned, our server is really simple. Our server struct has a store that's passed down as an argument, and all our server method is doing is calling its corresponding store method. And we have this red squiggly line here because we expect this method to return a slice of product structs, but this returns a slice of pointer to the product structs. And this is something I want to change here just to make things more consistent. And to give you a full picture on where this new server is going to be called from, I'm going to come to this main.go file here. And if you remember, we created our store here, so we can uncomment this and save this. And here's where we can call server.newServer and pass our store as its argument. This is going to give us a server struct, and what we can then do with our server is pass it down into new handler method, and this is going to give us our handler. But as you know, we don't have this new handler yet, and this is what we're going to work on next. For now, I'm going to comment this out and just leave as is, save this, and I'm going to create my handler file inside our handler directory. I'm going to name my package handler, and again I have a handler struct as well as our new handler method that returns a pointer to the handler struct with a context and the server. And below here is where we're going to add our handler methods. So I'm going to create this handler method called createProduct. This takes in a http.response writer, just like how we do in our standard HTTP package, as well as a pointer to the request struct. And here we actually need a struct to read our request body into. Only then we can do something like json.newDecoder to read our request body into our struct. We can create this struct in a separate file. So I'm going to create a file called types.go, name this package handler, and down here I'm going to paste the structs that I've already prepared. This product request struct is the representation of our JSON request body, and as you can see here, each of the field has this JSON tag to help us map each of the JSON request fields to the fields of the struct. And the product response struct is a representation of the response that we're going to send back to the user. So once we have our struct, all we have to do is call JSON new decoder and decode our request body into our product request struct. If there is an error, we can return a status bad request. Then all we have to do here is call our server.createProduct and pass in our context. And this method takes in a pointer to our store product, so we cannot just pass in our product request struct like this. So what we have to do instead is create our store product struct and pass in our name, image, category, description, rating, number of views, price, and count in stock. And at this point, you might wonder why we have to use a separate product struct when we already have this product request struct. This is because we're going to replace our server with a gRPC server in our later video. And a gRPC call requires us to define this thing called protobuf, which is just like a struct but in a different format, and pass the protobuf as its argument. So I think it's good to start now and create this separate struct because we're going to need a separate protobuf later on anyway. I'm going to make this a little bit more simple in a bit so that we don't have to repeatedly define our store product, but let's continue from where we left off. So this createProduct call is going to give us a product and an error. And if there is an error, we can return an internal server error. And down here, I'm going to create this product response struct with an ID, name, image, category, description, rating, number of views, price, and count in stock. This createProduct call doesn't return us a timestamp, so I'm not going to include that for now. And then we can call header.set as well as our status code, then encode our response in our response writer. I think there is an extra bracket here for some reason, and I'm going to save this again. And to make our life a little bit easier, instead of having to define our product response as well as our store product repeatedly, we can add these helper methods to help us convert our product request into our store product and also our store product struct into our product response struct. So with these, I can call to store product up here. Instead of creating our product struct here, I can call to store product and pass in the P like this. And I actually didn't know I spelled this wrong here. So this is going to be decoder. And down here, instead of defining our product response like this, we can just call to product response and pass in our store product. So that makes our life a little bit easier. And then now we can move on to our getProduct method. And because our getProduct endpoint is going to look something like products, and we're going to have to read the ID that's passed in as our parameter, the GoChi framework that we're going to use gives us a method called URL_param that allows us to read the parameter from the URL. And we're going to assign that into our ID variable. And because this ID is a string value, we have to call string convert.parseInt, pass this ID 10 and 64 to convert this into int64. This returns our integer value as well as an error. So if there is an error, we can just say error parsing ID. And you'll probably see that this chi package hasn't been imported. So all you can do is go mod tidy, and that's going to find and download that module for us. So back here, all we need to do is call our server.getProduct, pass in our context as well as our ID. This gives us a product struct as well as an error. If there's an error, we can return internal server error, and we can create our response struct, set our header, our status code, and our response. It is pretty much the same for the listProduct method. Let's just take what the Copilot suggests us. So we're calling server.listProducts that returns a slice of products, and we can iterate over these products, convert them into our product response, and append it to our slice of product response. Now we can move on to our updateProduct method. So the method signature is the same. And just like what we did for our getProduct, I'm going to get the ID from the URL param. And this gives us an ID. We can convert them into an integer. And first, read that request body into our struct. And before calling server.updateProduct, what we want to do is call server.getProduct to see which product this request is referring to. So this gives us a product struct as well as an error. If there's an error, we are going to return a internal server error. And what we actually want to do here is to patch our product request. And when I say patch, that means if the user only wants to update some of the fields, for example, just the name and the image, the patch request is going to allow the user to only pass in the values that the user is trying to update. So down here, I'm going to add this helper method to patch our product request. And what we are doing here is checking each of the fields of this product request struct and see if it's not empty, meaning we want to update this field. So if this is not empty, we're going to assign the value into our store product struct, and so on for each of the fields. And lastly, we assign our current time into our updated add field. And because our updated add field is a pointer to the time struct, we have this helper method to convert our time into a pointer type. Once we have this method, we can call this from here and pass in our store product as well as our product request. And we don't need this method to return anything because we're passing in a pointer type here, and we're just modifying this pointer type product on the spot. Now, using this product struct, we can call server.updateProduct, pass in the context as well as this product struct. This is going to return us our updated product, and if there's an error, we can return an internal server error. We can convert this updated product into our product response, set our header, our status code, and return our response. And before we continue with our deleteProduct method, there is actually one thing that we have to modify in our store product, and that is to add the updated add field to our update query here. So at the end here, I'm going to say updated add and pass in the updated add field like that. But this means we have to fix our MySQL test as well. So inside the test update product, on the success test case, we have this update query. So at the end here, I'm going to add this updated add equals to question mark field here. And same here for the failure case, we have an update query where we want to update or add the updated add field with the question mark like this. I'm going to save that and try to run this test to make sure it's working. So that's all good. Now we can come back to our handler and work on our deleteProduct method. So this one is really simple. All we have to do is read the ID from the URL param and call server.deleteProduct. Then we can return status no content, and that's all we have to do. We're now done with the product methods, and we still have to create methods for our orders. But before we move on, let's add our routing and test our endpoints. So to add routes, I'm going to create this routes.go file inside our handler directory. I'm going to name my package handler, and I'll define this global router, which is of type chi.mux. Save that to import, and I'm going to create a function called register routes that takes in a pointer to the handler struct and returns our router. Surprisingly, Copilot gives me some suggestions, but I'm going to group them together and make it a little bit more simple. So I can call r.route and define a products endpoint and pass in a function that takes in a router as its argument. And under this products endpoint, we take in a post request to create our product, as well as a get request to list our products. And inside here, we can create our sub router that takes the ID as its URL parameter. There's one thing I want to change here. Instead of a put request, I want this to be a patch request. So now that's a lot simpler. I'm going to get rid of these. And down here, I want to create a method called start that takes in an address as its argument, and we can return http.listen and serve that takes in an address and our router. Now we can call register routes from our main.go file. So here I'm going to define my server as well as my handler, save that, and pass that handler down into our register routes. Lastly, we can call handler.start and pass port 8080 as its address. Just one more thing before we test our endpoints, because I forgot to add this when we set up our database. I'm going to come to our db.go file and add this blank import like this. I'm going to save this and run go mod tidy. So if you don't have that, you're going to realize that your database connection is not going to work. And let's start by making sure that our database is running. So when I do docker ps, I don't have any container running. To run my MySQL container, we can call docker run on our MySQL container with all these flags. Press enter. We can confirm our MySQL container is running. Then we can do docker exec into our ecom MySQL container and pass in this create database query to create our database called ecom. Once the database has been created, we can apply our migration file like we did before. And all we have to do is do a docker run on our migrate container, specify the path of our migration files and our database connection string, and call up. Now our migration file has been applied. Let's cd into our cmd ecom API and run our Go file. So as you can see, the app has successfully connected to the database. And I'll be using Postman to test our endpoints. I already have this products endpoint as well as our request body prepared to save us some time. So let's see what happens when we make this post request. I'm going to send this request, and as you can see here, we got a successful response from the server. Let's create 2 more products just to make sure they're working. So I'm going to add product 2 and product 3. And now let's come here to see if we can list our products. So when we send a get request on the products endpoint, you can see we get an array of different products that we just created. Now, if we try to make a patch request to the product with ID equals to 1, and we update the name and the image of this product and send a patch request, you will see that everything else remains the same and it's just the name and the image that gets updated. Let's make a get request to see if we get the same response back. So we make a get request on the products with the ID 1, and again we get the same response back. Lastly, let's make a delete request and see what happens. So I'm going to delete ID equals to 2. That doesn't give us anything, but when we try to list the products again, that's going to show that we have 2 products now, just the ID 1 and ID 3. So we have successfully verified that all our endpoints are working as expected. While we're here, we can do pretty much the same thing for the orders. I'm going to come here, close my app, and start from the server.go file. Down here, I'm going to add methods for the createOrder, getOrder, listOrders, and the deleteOrder. Next, I'm going to go into types.go and add our structs for the order. We have the order request as well as the order response and the order item struct. And the order request has the slice of items as well as the order response. Now moving on to the handler, I'm going to scroll down to the bottom here and paste what I have already prepared for the createOrder method. And it's pretty much the same thing. We are reading the request body, calling the server.createOrder, and converting our created product into our order response, which is defined down here. So we take our store order struct as an argument and return the order response struct. And for the items as well, we call toOrderItems helper method here. And the only thing that's slightly different here is that we are iterating over these items and appending each of the order item into the slice of order item and returning this response. And you probably already saw we also have methods to convert the order request into our order struct. That's called from up here. And this also has a helper method that converts our slice of handler order item into a slice of store order item. And below our createOrder method, I'm gonna paste the methods for the getOrder, listOrders, and the deleteOrder. So we're doing pretty much the same thing. We are reading the ID from the URL parameter, calling getOrder, and converting this order into our order response. Same for listOrders. We're calling server.listOrders, iterating over these orders, converting them into the order response, and returning the response. And same for the deleteOrder. I'll save this. And now that we have defined our method, we can come to our routes.go and define pretty much the same thing for the orders. Again, it's the same thing as the products, except that we don't have the update endpoint for our orders. So now let's bring our app back up and test our endpoints on Postman. On Postman, I'm going to create this new request to localhost 8080 orders, and I'm going to make a post request with our JSON body. And I already have this example prepared where I have an array of items and other fields for the order. And since we deleted our product with ID 2 earlier, I'm going to change this to 3, and let's see what this gives us. We get a successful response with ID equals 1. It gives us the list of items as well as all the other fields that we need. Now when we make a GET request to list the orders, this again gives us the same response with the list of items and the fields we need. We can check our database to double check as well. And as you can see here, we have our order created as well as the order items that's associated with this order. So we have added our server as well as the handler methods and configured routing to our products and orders endpoints. And that is all I wanted to cover in this video. Thank you all for watching.